Hi everyone, I'm Trevor with North Valley Search and Rescue. Today we're going to explore another video in our rope rescue series. As always, this video is for use in conjunction with professional training for North Valley Search and Rescue within the scope of our SOPs utilizing our equipment. This video is not a comprehensive training package, but rather a small component of training and should be used under the guidance of a qualified professional trainer. There are many methodologies and avenues to achieve a desired outcome, but paired or performed incorrectly can result in injury or death. All ratings discussed are with new, fully rated equipment under perfect conditions, which never happens. Used equipment, time, UV exposure, use, application, or any other condition or alteration will change the load capacity. All ratings discussed are approximations and are simplified for your basic understanding purposes only, not to calculate the actual loads or forces. We are glad that you're here with us today, and for a quick reference back to this video and others of ours, please click on the red subscribe button below, or just below that, the add to button and create your own playlist. Might I suggest naming one SAR. So let's kick into today's video. In this video, we're going to look at gear inspections. Let's kick it off with ropes. There are three categories of ropes that we will see, and only two of which we will use in rope rescue. The first is a static rope. A static rope, unlike what the name says, it does have some stretch or dynamic properties to it. It's designed to stretch between, say, 3 and 10%. So therefore, when I'm pulling up a load, it will stretch just a little bit, but it'll still move that load. I do want it to have some stretch, however, so that when it comes down and it gets shock loaded, it will absorb some of that so that it will not just break. Static ropes are for rope rescue, and this is what we will use. You can know that it's a static rope because it has a two-color pattern. This has a base red with black tracers on it, so it has two colors associated with it. Static ropes typically are found between 9 millimeters and 13 millimeters. However, sometimes they're listed in SAE, which might be 7/16, ½ inch, etc. The next type of rope, which we should not see while we're using, is a dynamic rope. A dynamic rope is designed to stretch anywhere from 10 to 40%. This is often what rock climbers and ice climbers use because they know that they're going to take big falls on it, and therefore they want it to stretch to absorb the energy. They're not worried about moving something up or down as they're doing that in their own free will. Dynamic ropes can be visually indicated because this has more than two colors. Typically there's three. This one happens to have more. It's got a yellow base, and then it's got blue, teal, and pink tracers in it. So this is a dynamic rope. Dynamic ropes typically are found between 8 millimeters and 13 millimeters. The third and final category of ropes that we will see while we're in rope rescue are accessory cord. Accessory cord is effectively a smaller version of a static rope, and it is found anywhere from, say, 2.5 millimeters up to 8 millimeters. It's low stretch, just like, again, static rope. And those are the different categories and sizes of ropes. Now let's look at inspection criteria for ropes. We perform inspections on ropes when we put them away. The reason that we do that in our world of rope rescue is because when we get out onto scene and we need to go help somebody, we want to be able to pull and play with the rope. We don't want to have to spend time to inspect the rope before we go out, so it is your responsibility to inspect the rope before you put it away or while you're putting away. We can use two different clues. One is visual clues and the other is tactile clues. So visual clues being that I can see that something's wrong with it, and tactile clues is as I run my fingers along, oh, that didn't feel right. Tactile clue that is not passing inspection. So there are 5 criteria for failure of inspection on a rope. The first one being that the rope is 10 years or older from the date of manufacture. The second one is that we have excess wear, which might demonstrate itself as the core protruding, or we might have deformation or flattening of the rope. The third one is that we might have a burn. So we might have a heat burn So where it was put along some type of heat, being that friction, or it was set on a hot engine, something of the sort, maybe a lighter got put next to it, etc. Or we can have a chemical burn, and that might be from acids or bases, as we discussed earlier. Please don't pee on the rope, please don't put it on a battery, and please don't decontaminate with bleach. Our fourth inspection criteria is that we have a pronounced kink in the rope. So that's one, I can feel it, it's kinked. But I can also, if I go along like this feels okay, but what I do is I run the rope through as in a little bite here, and when I go along I feel, oh man, that doesn't feel right. And when I flip this over, do you notice how that creates a flat spot? On this side it looks normal, on this side it does not. So it has some sort of weird, something wrong with it, and therefore that may tell us that something's wrong with the core on the inside and we don't want to use it. The last one is stitching. If we have something that is stitched, a rope that is stitched, in this case we have, it's a loop of accessory cord that's in a prusik loop, and the stitching, if any of that's coming undone or it doesn't look appropriate, then it is time for that to go. Those are the 5 inspection criteria for ropes. So let's look at some of these up close. So as I run my fingers along here, and this is a good way to do it, I can feel that this doesn't feel quite right. This was burned, and this one happened to be because of heat, so it ran over a rock, around a tree, or maybe prusik ran along it, and it heated it up and it melted it a little bit. Right here we have a protrusion of the core through the sheath because the sheath is damaged. As I keep going, right here I can start to see that this is really getting beat up and frayed. This is borderline whether we would keep it in use or not, but that all intents and purposes should be removed. And then as I come along here again, oh, there's that weird spot. When I happen to flip it over on this one, it's flat. The end of this I intentionally left open, but our rope should not look like that on the end. Let's look at another one. This is a prusik cord, and as I go along on the prusik cord, ooh, that didn't feel quite right. And if you look, you can see just right down in here, there is a little bit of the white core protruding. And I'm going to go along again. Oh, there's more. There's another spot where the core is protruding. There's another one. So that one is up for failure. This is an accessory cord that looks okay, It's starting to look worse, and this is hammered in here. It's soft versus over here where it feels normal and structurally sound. This does not feel structurally sound. So this, and there's another spot, nice and soft, and this might be some of that flattening that I talked about where I can pinch it and I can get it to go a little bit more flat than it should. And then I'm going to pull up this cord, it's prusik loop, and as I run my fingers along, oh man, you can see right here that there are some chips, and that is, you see a little bit of glazing there, that's because this prusik was run really quick along something and melted. Right here I can actually see the core sticking out from the sheath. So that is how we inspect a rope. Now let's take a look at webbing. We have a few different ways that we categorize webbing based on their construction and their type. So the first one that we have is what we call tubular webbing. This happens to be 1-inch tubular webbing, and the reason that we call this tubular webbing, even though it looks flat, it is because it is indeed like a tube, very similar to a tube sock, where it is a full circle, and if I were to stretch this end to end and open it up, you'd be able to see all the way through it. The next type is flat webbing. This is flat webbing. It does not create a tube. There is no tube on it. It is just one flat piece of webbing. The next one is sewn versus tied. So in this case, I have a sewn piece of webbing. You'll notice that the stitching is up here. There are not very long tails because it doesn't need long tails. That is sewn webbing. This is tubular webbing that is tied into a loop using a water knot, and therefore it's got longer tails on it because this will slip. We can also categorize webbing by the type of material that it is. This is nylon, and nylon happens to absorb moisture, so therefore when it gets wet, it reduces in strength. This is made out of polyester, and the polyester does not absorb moisture, so therefore the strength reduction isn't really a concern for us when we're out in the field. We will not have much of this in our arsenal. Now let's look at some terms that we're going to hear when we refer to webbing. One of the first terms is a tail. This is a tail, so when it's tied, there will be a tail coming across. Okay? The next one is a loop. That is where it makes a full circle all the way around, and it can't come undone unless we untie or, in this case, unstitch the webbing. The next one is an attachment loop. An attachment loop is when we have a piece of webbing and on one end there is a loop that's either sewn or tied, then it's one single strand, then it comes back and maybe it's got another attachment loop at the other end. Now let's look at inspection criteria for webbing. Webbing should be inspected when it's put away as well as when you are pulling it out and putting it into use. It's short enough that we should be able to do that in a rather quick time period because it's not a 300-foot rope. It is maybe up to about 25 or 30 feet long, and it's relatively easy to do. So let's look at the inspection criteria. Number one is that it is less than 10 years old from the date of manufacture. So the webbing came off of a spool which lists the date of manufacture, and the date of manufacture should be listed on the end of the tail of webbing along with the length of that section. Number two is that there are no cuts, wear marks, burns, or stains on the webbing. This is what some of those may look like, is like right here we have, you can see that there are variances in the colors. This happens to be due to UV bleaching. We may have here where we have some wear marks along the end, and we have another example here where we have a cut going through the webbing. Number three is that there is no deformation or hardening of the webbing. So the webbing should be pretty pliable. I should be able to run it through my hands. I should be able to twist it, and it should look normal. This, however, when I run it through my hands, if you listen, it's a little crusty, and it doesn't quite have the same twisting properties. You can see that it's a little bit more rigid. It doesn't twist evenly. There's something that got into that. It may be some pitch, or it may be something else. Number four is we are looking to not have any burns on our webbing. So burns can come again from heat. So you can see this was pulled over something, or more than likely a rope ran over it rather quickly. So we don't want burns. This is again heat, or chemical being acids or bases. So please don't urinate on the webbing. Please don't store it next to batteries, and please don't decontaminate with bleach. And five, last but not least, is that we are looking that the stitching on these anchors is in good condition, the ends aren't sticking out, and that there's no abrasions here, looking like the integrity of it has been compromised. So those are our 5 inspection criteria for webbing. All right, now let's look at harnesses. There are 3 main types of harnesses that you may see. The first one that you may encounter is a seat harness. This type of harness is typically worn by rock climbers and ice climbers, mountaineers and alpinists. It goes around their waist, and it's got 2 leg loops to encompass their legs. This is something that's common that you may see people that bring their own personal gear that they might have. The next type, which I don't have an image of, is a chest harness. That goes around your two arms and comes together, cinches right here, and it is to be used in conjunction with a seat harness. That way, it encompasses all four of your limbs. If you're going to be hanging for an extended period of time, you can tie in slightly different shift where the attachment point is in relation to your center of mass, but it's got to be tied into both your chest harness and your seat harness. Then the third and final type is a full body harness, which has a chest harness built into a seat harness, so it encompasses all four of your limbs, and it is designed to be hung in the vertical environment for an extended period of time. Let's go ahead and take a look at the 5 components of a harness. The first component of a harness that you'll find is webbing. Webbing is found everywhere on a harness. That's what gives it its structural integrity, so you're going to find that. It's typically flat webbing if you watch the webbing portion, which was just before this. Then next are metal buckles. There are metal buckles on here which are designed to hold the webbing so that we can adjust it and we can make it fit to our body, because not everybody's body is the same. The third would be an attachment point. This case, it happens to be a soft attachment point made out of webbing. You can see here that it is sewn. On this harness, there are several attachment points. There is your primary attachment point here, which you'll notice is made out of metal. Then we have a sternal attachment point. We also have a dorsal attachment point, and we have 2 attachment points here, and these attachment points are not primary attachment points. These are used for positioning. Say if I'm in high angle rope work where I need to swing over to one side of the building to clean a window or to fix something, I can wrap a sling around that to hold me over, but I'm still being held up on my primary attachment points. The fourth one is padding. So you'll notice this has a lot of padding to help distribute the weight, and this one doesn't have quite as much because these are designed to be much lighter for when we're out climbing. The fifth component is a gear loop. The gear loops here are designed to hold gear like carabiners and pulleys and whatever else we may want to hang from a harness, but they are not designed to be tied into. These are not weight bearing, so please don't use them for such. And on this harness there are red ones, and there are actually gray loops along the edge here and over on this side as well that we can clip carabiners to and then hang things off of. All right, so let's look at a few other terms that you may hear when we are talking about harnesses. Some of those terms, one legacy term is doubled back. What that means is back in the day, we used to have these buckles that required you to go through the buckle and then back through it again, because if you just went through it once, it would wiggle loose. They've since designed different types of buckles so that that is a moot point because it just cams on itself and it locks itself in place. So you probably won't hear that so much anymore. The additional term that you may hear would be protective. Let's see if I can find one. This will work. Protective component. So for instance, this piece, which a carabiner goes through, and here as well, this is just made of webbing, and they have added these red, they're kind of like highlights on the side. It's not necessarily just for visual appearance. What it is to take some of the wear and tear of that webbing moving around on that carabiner. Over here, one of the protective components might be this plastic that's going around the gear loops, etc. So those are the terms in addition to all of the components that you might hear. Now let's take a dive into inspection criteria for harnesses. Harnesses should be inspected when you put them on, but you should also inspect them when you're putting them away so that we can go ahead and pull them out of service and purchase new ones if we need to. The inspection criteria for harnesses are fourfold. which expand out funny enough. So number one is webbing. So this is predominantly made of webbing, and webbing therefore has those 5 inspection criteria that we just covered. One is that it's less than 10 years old. 2 is that there's no cuts, wear marks, burns, or stains. 3, that there's no deformation or hardening. 4, that there are no burns, chemical burns, or heat burns. And 5, the stitching is that there's no loose ends, no frays, no abrasions on the stitching. So there is a lot to cover on here for the webbing. So on just my belay loop, I'm looking for the stitching, I'm looking for abrasions, I'm looking and feeling for hardening, I'm looking for any sort of burns, etc. So I'm going to do that all the way around the harness for all of the webbing. Then I'm going to, my second inspection criteria point is look at metal. And I'm looking at all of the metal components and making sure that there is no deformation, that there's no cracks, no fissures, no corrosion. So I'm going to look at each of these. Ooh, look at that one. That one's bent at a 90-degree angle. That is not how it should be. It should be flat like this one. So our third one is that on all of the stitching, whether it's on the webbing or not, is that it is structurally sound, so that there are not more than 1/4 inch on the loose ends, and that there's no frays or abrasions all the way through. Then we have our fourth one, is that we want to perform an operational check of the buckles. I intentionally cut this one, so we couldn't put it in service, so I can't check the operation of that buckle. However, this one looks like I can, so I'm going to loosen this back out. I'm going to pull, and when I pull on this leg loop, that buckle should lock down nice and snug. If I pull out a full body harness, it has the exact same properties. It has webbing, it has metal components, so very similar to carabiners and inspecting those. And I'm just going through all of the same checks. It's just that there are a lot of them on this particular harness. All right, let's look at helmets. So we have a couple of different types of helmets. What we have are soft helmets, which is just a foam. This happens to just have a laminate over the top, but it's still soft. So if you take this and knock it against the rock, it's going to put a ding in it. And then there are hard helmets. This is a piece of molded plastic or injection molded plastic, and it happens to have some foam on the inside to distribute the blows if it were to get hit by a rock. But if you hit this against a rock, then it's going to just push your head out of the way. There are a couple different ratings that you might find when we're talking about helmets. The first one is an EN rating, or a UIAA rating. Those are ratings in the climbing world that say this has met certain specs and certain criteria to be able to be used so that they meet a minimum standard. The next one is an industrial rating, which is an ANSI rating, which oversees a lot of the stuff that's related to OSHA in the industrial world, and so that's an ANSI rating. These typical climbing helmets do not meet those standards. Those industrial helmets you probably won't find in what we're doing. So when we are working with low angle, we typically will be using climbing helmets. You can use industrial helmets. You might use a Swiftwater helmet. You can use a bump helmet. All of those are fine because realistically we're worried about most of the time our heads hitting some branches as we're standing up in the middle of trees or knocking against a rock, etc. In the high angle world, I'm a lot more concerned about rock coming off of a cliff and hitting you, so therefore we need to have a climbing or industrial harness that's rated for that type of impact. Let's look at some terms when we're talking about helmets. So we have here the shell, okay? The shell of the helmet. This happens to be foam with just a laminate over the top of it. I have on the inside, I'm going to flip this upside down for you to see, I have a cradle, and this cradles around your head to adjust to your head size. Then we have adjusters, which back here, these are clickety-click-click adjusters. On this one, this happens to have an adjuster that's a roll knob, okay? And then I have webbing, straps, and buckles. The buckles can attach in different ways. Those are the main components that you're going to see on a helmet. Now, let's take a look at inspection criteria. There are 5 inspection criteria for helmets when we're inspecting them. Number 1, we're looking for the condition of the shell inside and out to make sure that it's structurally sound. So if I turn this helmet, you will notice that there is some structural disintegrity in a couple of places, and that has compromised its strength rating, so this is time for this one to be retired. If I look at this shell, I look around and I don't see any cracks or any punctures, etc. I'm going to look on the inside as well, and I can flex and extend to hear if I hear any clicking that may happen with these harder helmets as break or fissure rubs up against itself. Number 2 is I'm going to look at the cradle system, which on this one it goes all the way around, and I'm going to check to make sure that it is in good working order and that it is going to connect in all the spots it's supposed to connect. So same thing on this one, it connects here, here, down here, and that it is in good condition. Number 3, I'm going to look at the condition of the webbing and the stitching. Again, this goes back to our webbing inspection of the 5 things. It's not less than, or it's less than 10 years old. There's no cuts, wear marks, burns, etc., etc., no deformations or hardening. There are no burns, being chemical or heat burns, and the stitching, anywhere that there's stitching, that there's not more than 1/4 inch of stitching hanging out there. I'm also then on number 4 going to check the condition of my adjusters. So that holds there. However, right here it doesn't hold. So if you take a look, you'll notice that that has some burning. So maybe it just got too close to the fire one night. On this one, this has a little wheel and it tightens and it loosens appropriately. Then number 5, my last criteria is that the buckle connects and it holds and it releases. So same thing on this side. Those are the 5 inspection criteria for helmets. All right, let's dive into carabiners. So there's a few different ways that we can categorize carabiners. The first one that we're going to look at is the type of material that's made out of. The 2 common materials are going to be steel and aluminum. Steel is significantly heavier than aluminum. However, steel also has a higher load rating than aluminum for the most part when you look at the size and the shape of the carabiner. The next way that we can look at a carabiner would be whether it is a locking carabiner or a non-locking carabiner. So a non-locking carabiner, the gate just opens. The locking carabiner, it doesn't open unless we make an intentional action to unlock it. And then in this case, I have to make that intentional movement to unlock it. However, there are auto-locking carabiners that it automatically locks, and I have to, in this case, twist the gate to pull the gate open, and then when I release it, it automatically locks for me. When I'm looking at carabiners, we're going to look at ratings which are visible on each and every carabiner. If you don't see a rating, then it's not a carabiner we want to be using. So let's take a look at a carabiner up close now to see some of those rating numbers and what they mean. When looking at carabiners, there are a few different notations that I want you to pay attention to. On all of the carabiners, there may be miscellaneous letters and numbers such as this over here, this over here. Sometimes they're really long strings of numbers. Those are either certifications or that they meet particular standards or that it's a particular lot or batch number. But the ones that we're paying attention to are right here. So this one has an arrow that points to the left and to the right along the length of the spine. And right next to it, it says 28. So directly after that, it says 28. That means when the gate is closed, when pulled along the length of the carabiner, so from here to here, that it's rated at 28 kilonewtons. When the gate is closed, this one, it's got an arrow pointing this way, so when it gets cross-loaded, that is rated at 9 kilonewtons. And then the last one is when the gate is open and there is a load that's pulled along the length of the spine, that is rated at 8 kilonewtons. Okay, so this one up here again, it says kilonewtons, and it says along the length of the spine, it says 40 for 40 kilonewtons. So that's when the gate's closed. It doesn't have to be locked, but it has to be closed. Then we have up and down, and it says that when it gets cross-loaded, it's rated at 15 kilonewtons. And then it says when the gate is open, that it is rated when pulled along the length of the spine at 18 kilonewtons. This one up here, we've got, it says kilonewtons, and it says when pulled in this direction with the gate closed, that it's at 28 kilonewtons. When cross-loaded and the gate is closed, that is rated at 11 kilonewtons. And then if the gate is open, that it is rated when pulled in this direction at 7 kilonewtons. All right, so let's look at inspection criteria for carabiners. There are 5 inspection criteria for carabiners. When we look at a carabiner, this is what we want it to do. If it doesn't do this, then it does not pass inspection. The first one is that the gate opens and closes freely and completely. Number 2 is that when I open the gate and release it, it springs back and closes completely without my assistance. Number 3 is that if it has a locking mechanism, when it closes, it should lock. This one happens to be an auto lock, but some of these others, it would require screwing it shut to make sure that it locks, and then when we unscrew it, that it opens again. Number 4 is we're looking for the structural integrity of the carabiners. So we should not notice any major grooves, which we'll commonly find here or up here where the rope has run through. 1 millimeter difference in size in that groove was criteria for failure. We should not also see any cracks, deformations, or fissures as we go along and take a look at it. However, we might see some scratches, and scratches are okay, especially on these colored carabiners. It's anodized, so it's just like a color coating that's put on the top layer of the aluminum, which gives it that tint, and that will scrape off over time. But we want to make sure that there's also no corrosion on the carabiner. Number 5, the last of the criteria is that this pin right here, and when I flip this over, this pin right here, it's the same pin, is that it's in good condition because that's what holds the gate together. There have been instances where that pin did not get flattened and it would fall out. That was, those were recalled, but just be aware that that does happen, so you should be looking at your carabiners. So let's take a look at what each of those look like. So this carabiner right here, this one, you can see that it does not close appropriately. When you look at it from its side, you can see that the gate is at an angle. That is criteria for failure. The second one over here, this one again does not close. The gate does not quite line up with the nose there. So that is criteria for failure. And it also feels like, oh, that was just stuck. So that one, that's the criteria for failure. You'll also notice up here that there is a groove that is at least a millimeter difference. There's 2 of them, and there's one down here as well. There's a millimeter of difference there, so that's another inspection criteria that failed. This one, that one doesn't want to open, so that is a criteria for failure. It's also, I cannot twist this, and this should be an auto lock gate, so therefore it fails inspection. You'll notice that there are grooves up here, which are more than a millimeter, so those are up for failure as well. This carabiner, this one, oh, I cannot screw the gate, so it fails inspection. Then we have this guy right here, which just looking at it, you can see that there are some major grooves going on there. So some sand got inside of a rope and went through there and just shredded those up. This one is the same thing, that there are some grooves going through where the rope has been through. This is a little wire gate down here, and what this is designed to do, just because it's on here, I'll explain it, is this is designed to hold the carabiner in an orientation so that it doesn't get cross-loaded, where the load would be placed against the spine either way that it goes lengthwise. You'll see that from time to time on carabiners. And then this one appears to be in good shape. Let's unscrew the gate and open it up, release it, and it appears to be good. Now if you'll take a note of this one, so I'm going to try and line this up with the camera here, and when I open it, do you see how it shoots off to the side? So these don't line up, but it comes back and it closes. It's designed to be at this angle to give us a greater opening here, because otherwise it would stop about here, but we have that much extra movement to allow a larger object, so for this to go over the rail of a litter perhaps. Those are the 5 inspection criteria and what we may see on carabiners. Let's look at pulleys. There are 4 different ways that I categorize pulleys to be able to identify them and put them into certain buckets. The first way is whether it's a single pulley or a double pulley. So it's got 1 sheave, room for 1 rope, or 2 sheaves, room for 2 ropes. So a single versus a double. Then the next one is a PMP, which is a prusik minding pulley, versus a non-PMP, a non-prusik minding pulley. So this is a non-PMP. It's got rounded edges all the way around, where this is a PMP, and it's got a very sharp angle down here where it's got a block, a flat part on the bottom. And you'll notice that on these, this happens to be a double pulley, but it's rounded on one side and it's got this flat part here on the second. Here's why that matters. When I have this set up, this is designed to, with this prusik, is to hold the rope. However, when I start pulling the other way, the flat portion of this PMP blocks that prusik from sliding up into here, and it maintains the orientation that I want. When I move over to this non-PMP, watch the prusik slide up to the side, and then when this gets loaded, it pinches the prusik into the pulley. So it pulls the orientation out and it puts everything in a really bad position. That's the difference between a PMP or prusik minding pulley and a non-PMP or non-prusik minding pulley. The third category that we look at is a high efficiency pulley versus a low efficiency pulley. This is your typical hardware pulley where it's built. This one happens to have a plastic sheave on the inside, and this is not built high end, so it has a lot of friction on the inside, which means that I'm losing efficiency every time I pull, versus this, which has ball bearings on it, which moves very efficiently, so when I'm pulling, I don't encounter that resistance. Then the last category, the way that I break it down, is a fixed plate versus a swivel plate. So a fixed plate, these two plates, they don't pivot, they don't swivel, and it requires a carabiner to effectively close the rope on the inside of it, whereas a swivel pulley, these two swivel apart to allow the rope to slide in, and then it pinches back together. So I can put a rope in here, whereas that one involves me completely taking that off. Those are the 4 different categories of pulleys. We have a few different terms that we're going to use when we're talking about pulleys. So on this pulley, we have side plates. We have 2 side plates because there are 2 sides to a pulley. The next one is that in the middle, we have a sheave, or a pulley. Any of those terms are interchangeable. The third one is that we have a pin that goes through that holds that sheave in place. And this one happens to be one that you can tighten down with a wrench if it becomes loose, but it's got locking nuts on it, so that's part of your inspection criteria as well. We might have a swivel as a connection point up here. This is so that the ropes don't get twisted and they stay in their appropriate alignment. Then we also have on this one a becket, which is a connection point that's also pulling down in the direction of the load. It's another attachment point to be able to help you out with mechanical advantage. And finally, we have a release. And our release on this one happens to be a double release, but it's just a button up here. There's one on the other side as well to open our swivel plates. Now, let's look at the inspection criteria for pulleys. There are 5 points of inspection that we need to check. Number 1 is that everything that's metal on here, which happens to be almost everything, excluding that little plastic part right there, everything metal, we're looking for cracks, deformations, wear, or corrosion. So we need to look over the whole device, looking at all of the different aspects and making sure that it is all in good condition. Number 2 is that the plates swivel and lock as intended, if they're supposed to swivel. Number 3, the sheave turns as it's intended to turn. Some sheaves only turn in one direction, some turn in both directions. Number 4, the connection points up here are in good condition so that we can put a carabiner through there and that they are structurally sound. Number 5 is that this center pin is in place and in good working order. You would be able to tell that it is loose if we have play in those side plates. That is the inspection criteria for pulleys. I don't have any that are damaged beyond repair. Now let's take a look at DCDs, or descent control devices. We have 2 different categories of these. The first one is a static device, which is an ATC, or air traffic controller. And the second one is a camming device. In this case, it's a clutch, but it's designed to cam on the rope to get it to stop moving. Let's take a look at our ATCs. ATCs, or air traffic controllers, have 3 criteria for inspection. The first one is that the metallic piece does not have cracks, deformations, wear, or corrosion. So you'll notice this one, it's got some scratches and dings to it. But as I turn it over, it's got some pretty deep dings on that side, which has weakened the integrity of this, and that is criteria for failure. This one looks to be in good condition all the way around. The second criteria is that the teeth are present. This is a tubular device and does not have teeth on it. However, this one is designed where you can see up here that inside of each of these grooves there are teeth. And those teeth help to provide some friction. So when those wear out, then it's time to retire that device. Number 3 is that the retention loop down here is solidly in place without deformation. So the retention loop doesn't really have any structural integrity to an ATC. However, this allows us to put a carabiner on it and maintain this while we are threading the rope through the top so that we don't lose this. And it helps us to keep that with us instead of dropping it all the way down to the ground. So those are the 3 inspection criteria for ATCs. Let's dive into camming devices. I've got 2 different categories of camming devices. The first one is our personal use only, and the second one is rescue. This is not designed for the loads that we anticipate seeing out in the field. This is called a gree-gree, but there are other types of this. This works the same way that our big ones do that we use in rescue. However, it's just for small personal use, single person loads. So we're not going to use that. This is a camming device. It's called a clutch. This is what we use here at North Valley Search and Rescue. However, you may also see another device. This is called an MPD out in the field with other agencies. If we go do an agency assist, we don't use this in our organization. However, if you get on site and they ask you to operate this, if you don't know how to operate it, please defer to somebody who's qualified and competent to be able to utilize this. So let's go ahead and dive into the clutch here and go through some different terminology. Right down here at the bottom, this is an attachment point for a carabiner to be able to hook that up to an anchor or whatever we may be utilizing to set up our system. Then coming up, we have right here this side plate, and the side plate pivots or swivels, and the way that we open that is with this button. So this is our side release button. This is a double action, so it requires pulling that up twice to be able to get this to release, and then this pivots out of the way. So again, my side plate. Inside, I have a sheave, and this sheave is designed to rotate counterclockwise, but not clockwise. So you can pull with your brake hand, but it can't pull out the other direction unless you override that with a lever, which we'll talk about in just a second. On this sheave, it is attached to a control arm, which you'll see right down here, which allows this to pivot. And when I place a rope in here, this pivoting movement, this cams the sheave against the rope, against the actual body of this device, and that prevents the rope from paying out. So that's the camming device that we're looking for and that we're referring to. Moving on up the device, I have this attachment point up here. This is called a becket. This is used when we're creating a mechanical advantage system, and I have one pulley in here, I may have one up here to create a 3-to-1, but then I need to change it over to a 5-to-1 or maybe a 7-to-1 system where I need to put another pulley here. So a carabiner goes through here with a pulley, and if we're going to be utilizing this, this has to be with a swivel type pulley. It has to have a swivel per the manufacturer. It can't be a fixed plate. So that is called a becket, and that's what it's used for. I'm going to flip the device over, and on the back here I have a little indicator arrow that corresponds to different positions on the control lever. This control lever, the first position is stop, so when it's in stop position, it doesn't allow the rope to pay out. This, along with the rope tied off, is what we leave when we're going to walk away from the rope that's set up, ready to operate, or it's already tensioned and in operation. Okay. The next position is standby. This is what we use when we're hauling, so when we're pulling the system, like if we have a mechanical advantage set up. I can pull this around, and it's got release and anti-panic feature. So when I want the rope to be able to pay out, so I'm lowering somebody on the rope, then I use this control arm to override that cam so it opens back up, so it allows some rope to feed out. However, if I panic, the natural tendency is to pull harder, tighter. It locks the device, just like if it were in stop mode, so it cannot pay out anymore. Then you bring it back up parallel to the rope and reset it. So this is your control arm to go along with it. The last thing that we have right here is our friction plate. This is where my brake hand is holding on to a rope, and it's going over this friction plate, which helps us to control the speed and rate of descent of my party. We hope this video was helpful in understanding this component of our rope rescue system. Thank you all for watching the video. Remember to subscribe below to have quick and easy access to all of our videos. We look forward to seeing you in class and out in the field.